Good morning, my calculus doing friends. Today we're going to start on chapter 1. We're going to start with 1.1 in our note packet. I don't know if you can see that in our note packet. And so here we go. So here's the note packet and then 1.1 here. And so the first thing that they're doing is they're reviewing functions for us. And they tell us, first of all, what a relation is. And they say that's a rule of correspondence that pairs each element of one set, called the domain, with one or more elements from a second set, called the range. And so a relation can be a set of ordered pairs, where the set of first coordinates is the domain and the set of second coordinates is the range. Could also be the domain is the set of possible inputs and the range is the set of possible outputs. And so you can have, when they're talking about set of ordered pairs, any ordered pairs could be a relation. So 1, 2, 1, 4. This could be my relation. Those two ordered pairs. And I put them in my little set if I like. And I could look at those those two ordered pairs with a mapping that goes from the domain to the range. And so in the domain I only have 1, and in the range I have 2 and I have 4. And the mapping sends 1 to 2, and it also sends 1 to 4, and that would be a relation. And then they talk about a special relation, and that was the function. That's what they were going to talk about. And they say it's a relation that pairs each element in the domain with exactly one element in the range. And you can see that in my example here of this relation, that wasn't happening. This one element in the domain was actually being paired with two elements, not exactly one, in the range. And then this is kind of a joke, but well-behaved functions. And so you can see that each element in the domain is pairing with exactly one element in the range. Whereas this is also a function where each element in the domain is being paired with one element. It doesn't matter that all of the elements in the domain are being paired with that one element. And then I wanted to draw you a picture of something that's not a function. This is a relation and this is a relation, and they are also both functions. And I already did that, didn't I, right there? Here's one. You can even make it a dot if you want, like they have there. And it doesn't matter if you have another dot here that's acting appropriately. This is what makes it not a function. Okay, so here, problem 4, it says for us, I was going to look to see if I could see how long this recording is, and I guess I'll have to start using my phone to measure that because it doesn't show on here. Oh, it does. Okay, I see where it does. Okay, very good. Just getting used to the setup. Okay, the graph of f and g are given. So here's the graph of f and g. And it says state the values of f at -4 and g at 3. And so this x-axis hasn't been completely labeled, so just to make it easier, I'm going to go in here and do a little labeling so that we can see. Stuart does that a lot actually in the graphs that he has, is that he leaves off a lot of labels. Okay, so now I want to go where x is -4. So I want to go here, so from the center, and I'm going to go where x is -4. And then I want to check out, I want to go get on the f graph. So here's the the graph of F. Ooh, that's G, sorry. Here's the graph of F in red. And so I'm here at -4, so I'm going to go right here, and I want to know what ordered pair does that go with. So this ordered pair where I put that dot has an x of -4, and what the question is asking when it asks F at -4, it's asking what's the y value. And so you can see the y value is -2. So we can say that F at -4 equals -2. When you look in the back of the book to look at the answer, see what they have, they're just going to say -2 because that's what they asked you for. And then G at 3. So I'm going to go where x is equal to 3, and I get on the G graph. Now the G graph is, I think it's blue, and the G graph, so this is the ordered pair that they're talking about right there. And that ordered pair has an x value of 3, and it has a y value of 4. So G at 3 is 4. Then it asks for what values of x and f, for what values of x is f at x equal to g at x. And so when you're looking at this graph, where do you think that f and g are equal to one another? So that's one thing I really miss as a studio audience, people to respond back. So I hope that that you're thinking about it, because if you're sitting passively, it's not very helpful. You want to be thinking about it. And so, yeah, it's these places right here where the graphs intersect one another. And they're asking us for the x values at which they intersect. And so the x value that goes with this ordered pair is -2. So x equals -2. And so where's the other intersection? X equals 2. Estimate the solution of the equation f of x equals -1. And so now they're telling us, remember this over here is the output, the y value. And they're asking, when is the function f, when does it have an output of -1? So I'm looking right here, here's -1, and it could occur more than one time, and it would still be a function if it occurred more than one time. And so let's look here, here's the output. I'm going where y is -1, so here's the output -1, and I'm looking right here, and I don't know, to me that looked pretty good on -3, where it crossed -1. Maybe it was at -2.9, and so x equals, I'll put -2.9, is that one place, but it looks like to me that it hits over here too. And actually that one to me is looking like exactly 4. I mean, it's so x equals 4. That 4 is not very good, huh? Looks almost like a 1. Okay. Then it asked on what interval. Oh, I wanted to point out that how this would look if you did a function map of it. It would have -2.9 here in the domain, and in the range it would have -1, and there would be a mapping, right? And also it would have 4, and there would be a mapping to -1, right? Okay, on what interval is f decreasing? So we're supposed to be, my cat's going crazy here over the hummingbirds. The hummingbird activity is just crazy this morning. I mean, I'm like 9 or 10 hummingbirds attacking my feeder. It's just really, really fun to watch. They're asking when f is decreasing, that's where it's going downhill. And so here's the graph of f. We said graph f was red, and so you can see here that, and it's as you go left to right, because so sometimes people say, well, what if you went this way? That would be down. No, it's as you read left to right. So as I read left to right, it's going uphill. And then here it starts to go downhill. And I'm going to tell, when I say the interval on which it's decreasing, I'm going to tell the x values. And so it's decreasing here at 0, and it continues to decrease to x is 4. And so from 0 to 4. And right now, he doesn't make a big deal if you use the brackets or the parenthesis. What the parenthesis means is it means that it starts decreasing right after 0 and stops decreasing. The function ended there at 4. And what the brackets would mean would be including 0 and including 4. And so, and he doesn't make a big deal out of that right here in chapter 1. I'm not even actually sure which one he has in the back of the book on this. I usually look to remember, and I have to admit I didn't. And so we'll call it good. Then they want us to state the domain and the range of f. So the domain, I'm going to use a D for domain. That's all of the places that f goes. And f goes from -4, and it includes -4. So I'm going to use brackets here. And goes all the way, right? So here's x is -3, x is -2.5, x is, all those x's are included, all the way to x is 4. So starts at -4, x is -4, and ends at x is 4, and includes 4. And then the range is how low and how high does it go. So I'm now looking in the y direction here. So the lowest that f is -2, and it includes all of these values all the way up to y. So I hope I didn't say x is -2. I hope I said y is -2, right? The lowest it is, and goes all the way to the height of y is +3. Now this also includes some values for y is 2 here, and y is 1.5. No, that's 3.5, 2.5, sorry, and etc. But those are already included in our list, right? So the lowest it goes was y is -2, and the highest it went, including -2, was y is 3. So that's the domain and the range. And then this is problem number 9. Determine whether the curve of the graph is a function. If it is, state the domain and the range of the function. And so we're going to be thinking about the vertical line test. If I can draw a vertical line and hit the function only one time, then at every vertical line I draw, then it's the graph of a function. And so there isn't any place that I hit it twice. Every single one of my vertical lines would hit it only one time. If I had another piece of the function, which I don't have, but if I had a piece of the function that was like this, then a vertical line right here would hit it twice, and then it would not be a function. So, but that's not happening on this graph. So to the first question is state whether it's a function. So I'm going to say yes, it's a function, and I'm going to abbreviate function FCN. And then it asks me if it is a function to state the domain. So I'm going to state the domain here. And I'm also going to state the range here. So I'm looking for the domain. I'm looking for the x values that I would have, like for ordered pairs, right? And if I started listing these out, again, Stuart likes to not label the graph, but I mean, there's the x value -3, here's the x value -2.5, and you notice that every x value in between -2.5 and 3 -3 were included there. This doesn't actually exclude any value for x, right? Because there's x is -2, and this goes right up to something slightly smaller than -2, and then over here is exactly -2 and bigger than -2. The ordered pairs that would go with x is, right? only talking about the x coordinate of the ordered pair. And as I go here, every value for x is included all the way up to x is 2. So the range, the domain here is -3 to 2. And it includes those points. Stewart doesn't always carefully make a dot at the end, like he's done here to say he's including 2. You notice he didn't do that in this one up here on problem 4, but he was meaning that he did. So I guess if he just has it come and end at a place instead of coming and ending and having a dot, he's not meaning that it's ending at an open circle. So these he uses interchangeably, and he puts an open circle if he's meaning for it not to include that place. So anyway, but here he was careful and he put it. So the range, things are left out on the y's, right? So right in here, the y values, this is -1 and -2, the y values that go with between -2 and -1 are left out. And so our y values, the very smallest y value, lowest y value we have is -3. And we have every y value in between in the ordered pair, right? If we wrote these as ordered pairs, right? Wrote these as ordered pairs, and we're only thinking about what the y values would be, well, we would have ordered pairs that go between y values between -3 and -2, but would not include -2 because that's open. So we would put a parenthesis, and then our range picks up again. So we're going to put that together with, union that together with -1 all the way to our, thinking about our y values, where's the highest it goes? Well, that's 2 and 3, right? Because he doesn't label. I get some labeling going on there. So the very highest is 3. So that goes from -1 to 3. So if we were to list out all of the ordered pairs here, I know there would be infinitely many. The lowest one would be -1 for y, and the highest one for y would be 3, and everything in between would be included. And of course we would not be able to do that, and of course I started to write a parenthesis, so I get my eraser here, and -1 to 3. And so there, it's number 9. So here it says, find the domain of the function. So what would not be allowed is there was 7 hummingbirds. I could count 7 hummingbirds all pushing each other away at my feeder. Oh my gosh, it's so crazy today out there. Anyway, find the domain, number 32 here, find the domain, and you're allowed to have any value in the numerator. So if this only had a numerator, there would be no problems. Anything that you put in for x would be fine. You could find the output. The problem is you might remember that the denominator is not allowed to be a certain value, and that value is 0. So what I want to find is when x squared plus x minus 6 is equal to 0, because I don't want it to be equal to 0. So I'm going to cross it out and say not equal to 0. So I'm trying to find that x value. And in order to find that, I would need to factor this. And so this would be x times x. And I'm looking for something that when I multiply them together, I get 6. So on my factoring, 2 and 3. And I'm also wanting to make sure that in the center, when I subtract them, because this is a minus, I get 1. And so yeah, 2 and 3 works, where 1 and 6 doesn't, right? 1 times 6 does make 6, but if I subtract 1 and 6, I get 5 or -5, depending on how I put the signs. And I wanted it to be a 1 there in the center, because I just had x, so 1x. So it is 2 and 3. And then I want to make sure that I get the correct signs, so it doesn't matter what order I put these in. but I want it to be positive 3. So I'm going to put a positive here, positive 1, excuse me. So I want the 3, the bigger number, to be positive and negative on the 2. And I don't want that to be equal to 0. So I don't want x minus 2 to equal 0. So that's when x is not 2. I don't want x to be 2, because if x is 2, then the denominator will be 0. And I don't want x to be negative 3. So I'm going to exclude from the domain, all real numbers are good, except for the real numbers that would make the denominator 0 on a rational function, and that's what I have here. And so I want to exclude 2 and negative 3. And the book probably gets fairly fancy and doesn't just say that this is the domain, that x is not 2 and x is not negative 3, although informally that's what people would probably say. But formally they probably say something like this: the domain, and then they might do the set brackets, the set of x's such that x is an element of the real numbers, so any real number, and x is not negative, oh, it's negative 3 and 2. So I'll put x is not 2 or negative 3 there. Okay, so I'm going to exclude those. So something along those lines, they might say. And so we did a lovely job on that. You could also write it in interval notation. So the things that you've excluded here for x is 3, negative 3, and 2. You've excluded those, and you've included everything else, right? And so you could also write the domain. The domain is equal to, and then this is going to go from negative infinity to negative 3, and I'm going to exclude negative 3 along with negative 3 to 2, and I'm going to exclude both negative 3 and 2, and along with, then I'm going to pick up 2 to infinity. And so that would be another way that you could write it. And so you could write it like this, kind of really informally, and then this is set notation, that's interval notation for the domain. And here they're asking me to find the domain of the function, and then they have the square roots in there. And so you might remember that underneath the square root, you're not allowed to have a, what are you not allowed to have? A negative. And so the smallest that you could have underneath the square root is 0. And so we have 2 square roots, and so it's going to have to meet both conditions. And so we're going to have that 3 minus t, the radicand underneath there, that has to be greater than or equal to 0, and 2 plus t has to be greater than or equal to 0, because I want values for t that meet both conditions. And so my choice on how I solve this, and so I could add t to the other side and then rewrite it if you liked. So I could like add t to both sides, that'd be okay. And then I'd have 3 is greater than 0 plus t is t. And then I like to write it forward. I like to write that t then would be less than or equal to 3. So that's how I would like to do that. And then here I could take away 2, so that I get t is greater than or equal to negative 2. And then I would like, and I remember this is an and, so it has to meet both conditions. So I would like to put that on a number line so that I can kind of see that. And so here's negative 2, and we have that t is greater than or equal to, so that's here. And I could even maybe be tricky and get another color. Oh, I'm not going to be able to be tricky and get another color today because I haven't planned for that, and I don't have another color here. So here's 3, and t is smaller than or equal to 3. And it's an and, meaning it has to meet both conditions. So the stuff over here before negative 2, that's smaller than negative 2, does not meet this one's condition. Oh, it does meet this one's condition, doesn't meet that one's condition, sorry. The stuff in between meets both of their conditions, right? It's bigger than negative 2 and smaller than 3. And the stuff over here only meets this guy's conditions. So the answer to the and is only the stuff in between negative 2 and 3. So you could write that the domain, and you could use set notation. You could say is a set of x's such that, and then you could use that -2 and x in between, right? You could say this if you liked in set notation, that x is bigger than -2 and also smaller than, including -2 and including 3. So you could write it that way if you liked, or you could write it in interval notation, so that's set notation, and you would have something like this for interval notation from -2 to 3 for your domain. Okay, so we did a lovely job of thinking about that one, and I think I have a thing to do today, so I'm kind of watching my time, and I think I'll be able to do this problem, and then we will have to do the next problem in another video. So this is for asking me what f at -2 is, what f at 1 is, and what f of -1 is, and then it's asking me to make a sketch of f. And so should we answer those questions first, or should we sketch it first? It doesn't matter, probably. So here's this f at -2, and so when x is -2, let's see what condition we would meet. This is when x is smaller than -1. Well, -2 is smaller than or equal to -1. It's smaller than -1. So we would use this condition. So I'm going to put in where I see x, right? I'm going to use this condition of the function, and where I see x, I'm going to replace x with -2. And you notice that I put parentheses where I saw x. Did you notice that? So often students will ask me, you know, should I have just had this without parentheses? And the answer is no. And if what you want to do is just write it, instead of x, write parentheses, then go fill in the value that x is. And then you won't go wrong if you do that. So if every time that you're replacing for x, instead of x you put parentheses, then you go replace the value into those parentheses, you'll never go wrong. Parentheses are implied. So what that's going to then tell me is -2 squared, which is 4. So this is 1 minus 4, which is -3. And so that means that f at -2 equals -3. And when you look in the back of the book here, I don't know if this problem's in the back of the book, but it's just likely to say just -3. And then f at 1, so f at 1, so 1 is not smaller than -1. 1 is bigger than -1. That's true. So I'm going to use this one. So where I see x, I'm going to put parentheses, and I'm going to fill in the parenthesis with 1. So that's going to give me 2 plus 1 is 3. So f at 1 is 3. And then we have f at -1. So these are the 3 that it asked us to find. And this is if it's bigger than -1, and this is if it's smaller than or equal to. It happens to be equal to, so I'm going to use this one. So I'm going to have 1 minus, and then I use the parentheses squared, and I'm going to be replacing into the parentheses -1. And so we'll do that math again. 1 minus, and then -1 squared is 1. So this is 0. So f at -1 is 0. So if I'm going to graph this, this is part of, because the condition, so this is part of a parabola, right? Because it's x to the second, and then this is part of a line. So I'm going to have on this graph over here part of a parabola and part of a line, and you can pick a few points just to kind of get how it goes, or you can use your shifts and translations and all of that. So you could be saying, well, this parabola, you know, looks like this, and because it's minus, that means it's upside down, and because you have the 1, that's going to raise it up 1. And so you could do that if you wanted. And so from the standard place that would have been, which is at the origin. And then you could go and make sure that your domain is only before -1. Now, that's fine. That's lovely, in fact, and I know that if that's what you want to do. Now, if you wanted to, I would probably just pick a few points just to make sure. That's just me, and I wouldn't pick a lot of them, just a few. And so I would pick like -1, and I already did that. We got 0. And maybe I would pick -2. And we already did that. We got -3, and maybe I would pick -3 just to have one more on there. When I put in -3 here, remember that the parentheses are implied, right? -3. So when you put that in there to see the output, you're getting here 1 minus 9, which is -8. And so I'm going to go plot those on my grid over here. So -1, 0. And -2, -1, -2, -3, 1, 2, 3. And -3, 8. I think this is 7, so 8 is here. And so here's what I have. And this thing would have come here like that, right? Because it was up 1. And upside down. So if this parabola had been in its entirety, it would have gone up to here and then back down, right? Okay, so we just have that part of it over there. Then we're going to have a line over here. And I'm just going to pick a few points on the line. I'm only going to pick 2. I'm feeling really tired, and I have, I'm going to be late if I'm not careful. So -1. Now, I know that it's bigger than -1, so this should be a hole in the graph at -1. And at -1, this would be, when you're replacing, right, 2 times -1 plus 1, so that'd be -2 plus 1, that's -1. And then maybe I'll pick 0. When I pick 0 in there, I get 1, and maybe that's enough. So at -1, I have an open. That's my open. And at 0, I'm out 1, and I can go here. I'm going to use my slope. My slope's 2, right? And so I'm going to use my slope over 1 up 2, just to help myself draw that straighter. Oh, look at your paper. I'm looking at my screen and not my paper, and oh, it almost made me dizzy. Okay, so that's kind of how that one looks, and we'll do the rest in the next recording.